Alright, ladies and gentlemen, welcome to Unit 1, Lesson 12 in our math series, Math Expressions. It is solving numeric proportion problems. So we're going to be taking a look at what a proportion is, just in the nuts and bolts of it. The two equivalent ratios beside each other and being able to solve that. So that's what we're going to be working on today. So what I want you to think about as we're doing this is that think of proportions as like batches of your dessert recipe or whatever you have there. And so if you're thinking about it in that way, it's much easier to think, okay, if I'm making brownies for 5 people versus 20 people, I take the same recipe and I just multiply it to fit my serving size. And to make them the same ingredients with the same taste, you need to have the same stuff with it. So the oil, the water, the chocolate, all that gooey goodness there. So remembering also in a factor puzzle, you need to label and look. Okay, and so if the first part of your ratio, remember if you have it written there, you would have 3 to 5. The top of your factor puzzle would be 3 and 5. And this would be our equal sign. It's taking a while to get there. Okay, is equivalent to 6 to 10. I will put this same thing right there. So let's take a look at what that looks like. So we're looking at this factor puzzle. This is number 1 in your student booklet. I believe we're on page 31. And so what I want you to be thinking about here is, how would this look as a factor puzzle? So what we do is we take the parts. So we got A. We're trying to solve for A. So think about this as like we have Billy got this many apples to Jamie's 32. If Billy had 15 apples and I guess Jamie had 40, how many did Billy have in the first place, or whatever it was? We're trying to figure out this equivalent ratio that when we use our factor puzzle, we're going to solve it. Imagining these as like rows of an extended ratio. So I'm going to put A here. I'm going to just leave it blank. So whatever was here, that's what we start with. And then we got 32. That's going to go here. So whatever we figure out to 32 is equivalent to or equal to, that's like the 4 dots, 15 to 40. And so we solve this using a factor puzzle, thinking, okay, what factor is 32 and 40 in common with? The answer is 8. Here, 15 to 40. My thought is, well, 8 times what gives me 40? My answer is 5. Okay, so 5 over here, because they're both, this is the 5th row of whatever basic ratio we get up here. All right, so we got this 15 times, or divided by 5 is going to give me 3. So this is my third factor. So my basic ratio, or my unit rate for this ratio, is 3 to 8. So for every 3 apples Billy gets, Jamie gets 8 apples. So keeping that in mind, well, 8 times what gives me 32? 4. So if that's the case, I got to put 4 over here. 4 times 3 gives me 12. Yeah. So when Billy got 12 apples for A, Jamie got 32. Using that in place, what you need to remember is, if it starts first, it's going to start on the left. If it's second in the ratio, it goes on the right. Order doesn't necessarily matter, but when we're using a factor puzzle like this, we don't want to mix up the ratio to be 36 here and 16 here, because then we also have to do it on this side. This would become 63 to T. So in your workbooks, I want you to work on problems 2 through 6. Next, we're going to be looking at whether or not it's proportion or not. So you want to turn to page 32 in your books. What you want to be looking at is, if you think it's a proportion, the problem must be that it's an increasing or decreasing amount proportionally. So you want to be thinking, is it increasing at the same rate as you go to one proportion to another, or is it decreasing at the same rate? You want to be thinking about that as you're going through this. So, number 10, Peachy Paint Company used 20 cans of blue and 15 cans of yellow paint to make grasshopper green paint. They have 8 more cans of blue paint. How many cans of yellow paint do they need to make more grasshopper green paint? So, we want to think, okay, if I were to make green paint and I have this much blue to this much yellow, if I end up adding more blue, do I need to add the same proportional amount of yellow? That's what we're thinking. My answer to you is absolutely yes. And so what we want to be writing in here is this is a proportion problem because you need to use the same parts of blue to yellow to make the same shade of green. Okay, so we're thinking about that in our heads here. I'm going to make this a little bit bigger so that you guys can see. If you need a pause, you can do that. So since it is a proportion problem, what I would do is I would set this up to be a proportion as an equivalent ratio. So we got 20 cans of blue to 15 of yellow is equivalent to, or 2 colons, is equivalent to 8 to y. So I'd set it up just like this. So 20 to 15 equals 8 to y. And so I'd do that and I should get 5. I would have here as being 4, because these are factors of 4, or these are multiples of 4. 4 times 2 gives me 8, so I'm going to put a 2 over here. This is the second row, and here this is the 5th row. 5 times 3 gives me 15, and so that tells me that for every 4 parts blue, this would be blue, so I'm going to label it B, I get 3 parts yellow. So for every 4 cans of blue, I need 3 cans of yellow, whatever that would be. So if that's the case, I would need 6 more cans to make my same color. So y equals 6 cans. What you want to do during this time for 11, 12, and I believe number 13, you're going to look and see and think to yourself, is this increasing at the same rate? Or are we seeing different patterns? If it's something that is a different pattern, it's not proportional. But if it's increasing at the same rate for both parts, it is a proportion. They are equivalent ratios. So with that, that's our lesson on identifying and solving proportion problems using numerical amounts. You know, just setting it up like this and putting it into that right there, the factor puzzle, and then solving.